I'm Tom Hall. I'm an artist and Cycling 74 employee. I'm based out of Los Angeles, California. Cycling 74 is a company who makes and develops a visual programming language called Max. This has been happening for quite a while. Nearly 20 years, actually, 20 years next year. And what started as just Max now includes a number of programming elements. It includes Max, MSP, Jitter, and what you're here for today, Gen. Gen you may have heard of before since its first release almost 6 years ago now as part of Max 6. In recent years, many programmers have started to harness its power to push their ideas and programming into areas not possible before Gen. It's becoming quite prevalent amongst the Max and Max for Life communities. Let me introduce you to what we call the secret world of Gen. It's not a dark art though, as some people have said to me before this presentation. It's an additional patching environment that is built into Max. You might already be using Gen in your music practice without even realizing. It's included in a number of plugins, devices, and the code produced in Gen you'll even find inside of music applications. It works similar to Max in the way that you patch objects together. However, there are some important differences. It has a reduced but highly optimized object set. So you don't get 1,000 plus objects like you do in Max, but the ones that you do find are really optimized to work well. It addresses audio signal on a per sample basis. This is a big one, rather than in vector buffers, which we do in Max. And it compiles code as you work. And you can either run or export that code, or even not look at it. An area where you'll find Gen is inside of a number of Max for Live devices. One popular Max for Live device that includes Gen is Convolution Reverb. It's a fantastic sounding reverb that harnesses the power of Gen to create realistic environment-based ambience. Let's take a look and a listen to this. Now, while this device is pretty complex behind this UI, what I really like about it is it's relatively easy to use. And I'm not sure if you know, but there is a whole slew of impulse responses out there on the internet. One website that I quite like is called Echo Thief. And there's thousands of impulse responses on there, and what's really great about them is they're all geotagged. So there's one that I really like called JFK Underpass, and you'll hear the difference. So it's like you saw there, I just simply dragged it in, completely different sound. There's a ton of Gen in the back end of this that's making all of this work and really well optimized. Another live pack that heavily utilizes Gen is the popular Surreal Machines pack. They use the unique functions inside of Gen to emulate a variety of hardware. Recently, they used Gen for a popular VST and AU plugin series for prototyping code development, and they even used Gen in the final product. Let's take a look at this magnetic device. I really like this one. It's an emulation of the classic, you might be able to tell from this mode selector dial, the classic Roland RE201 Space Echo. This one. I love that device. It's getting a little hard to find a cheap Roland 201 these days, so that's a great alternative. Another area you might not be aware where you'll find Gen code is actually inside of a number of iOS applications now. One iOS developer who uses Gen is K-Devices. You may have heard of them. They make a variety of modulation-based Max for Live devices. Their Max devices are awesome. But they use Gen to create the audio engine for their iOS app, Shaper. Shaper is a complex wave shaping tool that adds glitchy wave folding and distortion to your audio signal. It's relatively simple, it sounds fantastic. So let's take a look and a listen to Shaper. Another iOS app that uses Gen is the Mobius Lab app by the fine folks over at Amazing Noises. You may have heard of them. They make a range of Max for Live devices. They also make a series of Max learning tutorials and books as well. Mobius Lab is a multimorphic sound processor that's both a synth and a sampler in one. It has a ton of effects built in and over 200 LFOs that you can apply to almost every parameter in the application. It's pretty phenomenal for an iOS app. So let's take a quick look at that. Now, I know those demos were a little on the noisy side because I love noise. I definitely sit on the experimental side of the music spectrum. But those two apps can do much more angelic stuff. They're very versatile. Another area that you can find Gen in addition to software is hardware. This is a new one to a lot of people. Recently, Gen's become a tool for creating code for a variety of hardware devices. And one of the first pieces of hardware to support Gen were the OWL, Eurorack, and guitar pedal devices by Rebel Technology. You can see here in the middle, the big one with the 8 knobs is the Eurorack model. The way that this works, the way that you produce code for the Eurorack or the OWL guitar pedal is you develop a patcher inside of Gen. There's an export function for that code, and you upload it to Rebel Technologies cloud. There, a small bit of cross-compilation happens, and then it's downloaded back down to your attached OWL device. And this actually all happens just in a matter of minutes, a minute and a half. And then what's amazing is the code is immediately running on the hardware. What I really love about this and what changed it for me was you can detach the hardware straight away, just unplug Max hard and shut your computer down and take the hardware off to a gig, reboot it, and the Gen code will be there on the device, just ready to run. You only have to do that process once. Recently, Gen code export and cloud compilations being extended to the versatile mod devices Mod Duo. They're based here in Germany, in Berlin. I'm not going to go into that because we actually have them along today as guests, and they'll be coming up a little later to show you how it works. So let's take a look at some Gen patching examples. So as mentioned, in Gen, you work on the audio signal on a per sample basis. This is different to the familiar Max environment where we work on blocks of samples at a time. One of the great things about Gen is the additional functionality it provides you within Max, and you can still patch in the real-time audio domain. So just like in Max, you're patching in Gen, it's the same thing. The way that this works is, Max is the host for Gen, which is an object, and inside of the Gen object is the patching environment for Gen. Max provides the content, audio signal, parameter control into Gen, and then from Gen, Max, the host, still controls amplitude, volume, and then routing elsewhere of the signal and/or data. So this brings me to one of my favorite parts of this, is as I mentioned, Gen works on the audio signal on a per sample basis. And you might be thinking, why is that different? Well, it allows us to do single sample feedback loops. And what this allows us to do is emulate a variety of hardware. So we can create new oscillator and filter designs in Gen. And this is something that was really difficult to do before Gen. The only way that you could do this before Gen in Max was to make your own Max object, which meant coding, which meant writing in C or C++. And for some of us, that doesn't work. That's a little tricky. Let's take a look at this example. And this is actually one of the first examples I got to see actually before Gen was released, and I was pretty much immediately sold. It's an emulation of the classic Moog ladder filter. Sounds great. I sold all my Moog ladder filters pretty much after. I was like, I don't need them anymore. And what makes that work and what allows us to get that great filter sound is that there's a number of single sample feedback loops inside of there that allows us to do that filter design. So Gen works inside of Max with its own patching environment. What this means is it also has its own special set of objects. I mentioned before, it's a reduced object set that's highly optimized. Some of these objects will be familiar to Max users, and some of them won't be familiar. So let's just take a look at a couple of those objects that are not familiar, and that you'll only find inside of Gen. So here I just have a simple feedback delay. And I have a parameter here running in from the Max host environment into Gen that's allowing me to control the feedback. It's pretty smooth, there's no glitching, because I'm using this new unique object that you can only find inside of Gen called the history object, and this allows us to do that single sample feedback loop without killing the audio. In addition to that, we have this other object that you don't see in Max called param. And this is doing a couple of things here. It's setting the parameter for our feedback amount, which is just before the history object. And it's also exposing the parameter back to the max host, as you can see here. There's a ton of other objects that you will only find inside of Gen. So, essentially, Gen allows you to make your own custom compiled MSP object without leaving Max. And even better, without writing a line of code. I'm a fan of that one. However, for you folks who like to write lines of code, I get it, it's fun. There is a textual coding environment that is inside of Gen, and it's called Codebox. It's actually its own Gen object, and I should mention, but it only works inside of that Gen patching environment. You can see here, it's relatively simple. Out 1 equals in 1. That's just a basic bit of Codebox text there. It allows you to write, edit, copy, and paste your own DSP algorithms inside of Gen. The code that you write inside of Codebox is similar to C or JavaScript, and it has a relatively simple set of operators that relate directly to the same visual objects that you can find inside of the Gen patching environment. So, let's take a closer look at some patching. So the way that you move into Gen and into Gen's patching environment is simply double-clicking the Gen object from the max host. You need to make sure that it's locked, and then just double-click Gen. This is the default Gen patching environment. This is what you'll see every time you instantiate a new Gen object inside of Max, and then open up the Gen patching environment. You'll be greeted with this. If I go ahead and delete this patch cord, the sound stops. And that's because, just like in Max, we're patching the real-time audio domain. You might see that this default patcher has a similarity to sub-patches in Max. We have inlets at the top that's providing content into the Gen patching environment, and then we have an out one down the bottom, which is sending whatever we've created in Gen back to the Max host. Another thing you'll see inside of here, and some of you who know Max may have noticed that there is a few extra icons. We have this loop icon down the bottom here that's yellow. And you'll see that it says disable auto compile. And that's because auto compile is on by default. And that's going to make the most sense to Max users, because we're all used to programming in the real-time audio domain. But if you wish, you can turn it off and make a change. And you'll notice that this hammer icon became highlighted when I deleted that object, so that I can manually compile the patcher as I go. So sometimes it makes sense to develop code, but not compile at the same time. Developers like to have that as an option. To the left of the hammer is the reset icon, and what it allows you to do is, if you have, you must notice seen the parameter that I had set in a previous patcher, you can set a default value for your parameters. At some time, you may change that number, but this reset icon allows you to reset any set parameter back to its default value. It can be useful when you're patching away. There's one other icon over to the side here, and it's this C for code. If I press this C for code, you'll see that this sidebar opens up. And you'll see there's some syntax there. Now what happens is when we patch in Gen, in objects, this syntax is automatically written in the sidebar. And you can actually keep the sidebar open and see this code being generated in real time as you patch. It's pretty cool to see. And if I go back over here and highlight, just rejoin that as patch code. If I highlight these objects, the syntax that relates to the patch will be highlighted as well. This is actually a really great way to start working with Codebox, because the syntax that you see here in the sidebar is what we write inside of Codebox. So you can just start patching together objects in Gen and get an idea for what the code looks like. It's great. I love it. I love that part of it. So let's add some amplitude modulation to this signal that we have running into Gen. And keep an eye on the sidebar to watch the code being developed in real time. So I'm going to put in a multiply object here. Did you notice that there was some new code added to the sidebar? And now I want to modulate the signal. So I'm going to make a cycle 0.1. But there was no syntax added. And that's because until I draw a patch chord from the cycle to the multiply object, it's not part of the patch yet. So there's no reason for the Gen patching environment to write any code yet. But watch the sidebar. Boom. There we have it. Some new code. And then if I highlight over these two objects, you can see the syntax that's related to them that I just added. And you should be able to hear.
Give me that bass, give me that kick drum, keep me loose like Valium. If you put a party at, I need some of that primitive action. Give me that bass, give me that kick drum, keep me loose like Valium. If you put a party at, I need some of that primitive action. Give me that bass, give me that.
There's one other object I want to mention that I touched on before, and that's Codebox. Let's bring it in. It can just be used like this. So actually you'll notice Codebox looks a little different to what I showed before. And basically Codebox here is just joining the in objects to the out. So if I just join it in like this, so Codebox allows you, as mentioned, to write your own DSP algorithms using language that is similar to C with a relatively simple markup. However, you don't need to write your own DSP algorithms, and this is one of the great things I like about Codebox. You can go ahead and find thousands of DSP algorithms already written out there on the internet and bring them into your patching. And to get them to work inside of Gen is actually a relatively simple process. It doesn't take too many changes to get them functioning, which brings me to stealing other people's work. No. Using other people's work. That was the word. So to avoid internet hassles, and I'm really glad I did this after seeing the spotty Wi-Fi yesterday, I pre-made this video where I head off to the internet, grab a piece of DSP code, bring it back to Max, and adapt it into Codebox. So please join me in watching this video.
Here we have a simple Max patch setup with a sine wave running through Gen. If we head over to our web browser and navigate to musicdsp.org, we'll find a range of code for various effects already written and available. Let's use this wave shaper code. It looks kind of like C. Let's copy it. Navigate back to our patcher. Open up Gen. Let's use an object called Codebox. You can pretty much write any sort of C as long as it doesn't do anything with pointers or arrays. Now let's paste our wave shaper C code into Codebox. Okay, it looks like we have some errors here, and this has caused our sound to stop. We don't need this in_to object, so delete that. In Codebox, we also don't need these variable declarations. And input in Gen is simply in. Also remove this variable declaration and change output to simply out. Click outside of Codebox to compile again. Shoot! Looks like we have an error still. Okay, this last one. Fabs. Fabs in Gen is actually abs. And now we have it, our newly dirtied up cycle tone with some DSP code we nicked off the internet. There's plenty more out there that can be used inside of Codebox.
There you see, I don't really say shoot. I don't know where that word came from. Anyone who knows me well knows I have a vast vocabulary of bad words. Better than that one. Okay, so that brings me to introducing my guest who I mentioned before, the guys from Mod Devices who are going to run you through how to develop a piece of code and get it running on their hardware, the Mod Duo. Please join me in welcoming them. Gianfranco from Mod Devices. By the way, I have a Mod Duo and I dig it. So it's great to have these guys along today.
Hello, everyone. It's a big pleasure to be here. Thank you so much for the cycling guys to invite us here. Actually, it has been just 1 year that we met Tom on the previous loop, and he went to our office and when it all started, so it's really nice to be here again. So I'll do a very quick intro on what we do, and I'll call Nino to actually talk about Gen a bit more. I'll go as fast as I can. So we are Mod Devices, and we do a digital platform for performing musicians. And from a developer's point of view, what we have is a hardware plugin host, which is in a box, very sturdy and stage ready. It has audio inputs and outputs, has MIDI support, and we offer this remote interface in which you can patch everything together, pedals of all kinds. It's a plugin-based system, and you have all kinds of plugins, MIDI or audio. You patch everything together, make these pedal boards. You can make as many as you want and take them to the stage, okay? From a system overview, what we have is actually a computer that has an ARM general purpose CPU inside and not a DSP. It has an operating system, a real operating system. We have a plugin standard that we support, and we have an online plugin store where developers can publish code, publish plugins, and distribute it to the community. In terms of operating system, we use Linux. It's quite expected. It's a real-time patched Linux. It's really nice because it has a large existing code base. It has audio libraries already built in. We can build in more packages if necessary. And because we are not using a DSP, but a general purpose CPU, it's mostly about cross-compilation. If it runs on your desktop, it will run inside the Duo. In terms of plugins, we use a standard. Everybody asks if we support VST, but no, we support the LV2. It's the standard that was created by the Linux community, and very similar to VST on the sense that it supports audio, control ports, MIDI, and control voltage. It has a clear separation of DSP code and interfaces and metadata, a very liberal license, which is very important for us when I'll talk about the store. Hundreds of plugins available. We have about 200 on the store, all open source. You guys can all check the code, just like Tom showed for those internet code. And the website, lv2plug.in, all the documentation is there. And our plugin store, it has at the same time commercial plugins and free open source plugins. They live together. We have an online compiling system, so you don't have to assemble a toolchain on your own machine. And because the plugins are all C and C++, and as just Tom mentioned, not everyone likes to do C code, we have these integrations with the MaxMSP, Pure Data, and Faust. And the plugin store, just let me show you here, very quick. You can publish the plugins, the users can, it's just like the App Store from the smartphones, and user can just, with a simple click, install a new plugin. And I'm going to call now Nino here to go through the MaxMSP integration, which is what we actually want to show you guys. Please welcome Nino from the Shido plugins.
So I'm Nino, good to be here, and I will tell you a bit more about the integration of Gen in a mod duo. So if you have a mod and you would like to make your own Gen plugins, a good place to start would be with the mod duo package. It's a package which you can find in the package manager, and it's made in collaboration with Cycling74, and basically allows you to export your code directly to the mod from the environment of Max. Normally you would install it, we already installed it, and if you click on launch, you will see some documentation below, some tutorials, walkthroughs, things like that, and a couple of examples. We'll start with those. So we have some basic setups that allow you to bypass your audio, and this, for example, is a vibrato with some comments. So it's basically pretty simple. This is the code, and the parameters here. Those are controllable from outside Gen. And this is just the object-based example. But like Tom said, you can also use Codebox, which looks like this. And we made an empty one to get you started. So yesterday, I heard Dose1 talk about Flanger, and he didn't really have use for it. But I thought, well, what if hair metal comes back? So I kind of prepared something for that. So I made a Flanger. Which looks like this. And I would like it to run it on a mod. So there are a few things I have to take care of before I export it. All the code that is exported to the mod has to be inside the Gen object. Nothing outside will be into the final plugin. The mod itself runs at 48 kilohertz, so all the math should be correct, or the sample rate conversions, or anything like that. And if I want controllable parameters, I should define the param objects with the names and the values, default, minimum, and maximum. And then if that's all right, I can click this message box here. But like the internet wasn't really good right now, we already exported it. So it ends up in this cute tuna box, because it doesn't have a GUI yet. You can add that later, but first it will be inside the tuna box with the parameters we defined inside the Gen object. And we'll probably want to know how it sounds. So I cheated a little bit there. I added the shimmer reverb I made. Also in Gen. So, and the mod has multiple inputs, so we can connect everything and have a delay on my voice, etc. So, so I think Tom might take over again. And this was a small demonstration of the mod capabilities with Gen. Thank you.
Thank you.
With the internet.
That was pretty cool. I got to admit, after being a Max user for many, many years, the first time I was able to press code export and put it on a piece of hardware felt like a pretty empowering feeling, and especially taking it off somewhere in the backpack with no laptop. It's pretty exciting times. So as you can see from what Nino was showing us, the patching environment is very similar to Max. And once you get in there, just like in Max, there's a whole range of help files and the likes. You can see there's tons of Gen documentation. And there's also, if you go to our website, a whole range of tutorials dating back to when Max was first released. There's some phenomenal LFO tutorials by my colleague at Cycling 74, Gregory Taylor, has done some amazing tutorials. So I want to wrap up. As we've learnt, Gen is a part of Max with its own patching environment inside Max, but it's a little bit different. It does have a restricted object set, but those objects are highly optimized. Gen makes code as we work, and we can either just ignore it or we can export it and use it elsewhere. Gen allows you to make more substantial Max programs, iOS applications, plugins, etc. And as we saw from the mod devices guys, Gen works with hardware. Okay, cool. Thank you for your time. You've been a fantastic audience.